So let's continue. Now we will try to make a mesh. For this purpose we will use a very good program which is called ICEM CFD. But at first we must make very important change in our properties. Right click on the geometry, select properties and change analysis type from 3D to T2D. It is very important, so do it in case. I will even draw here. Okay. Now we will choose ICEM CFD component and put it on the work table. And transfer geometry to ICEM. Now they connected by this line, and it means that the geometry from this part transformed to the model of ICEM CFD. Let's open ICEM CFD. To double click. Now it's opened. I think I'm not right. Better to close the geometry. I forgot to close it. We see the geometry which we have built, did build on the previous lesson. Go to tree, open geometry, mark points. It's okay. And now we should make the parts of this geometry. The parts are important for making the boundary condition. We will put boundary conditions on these parts. We have the following parts: the inlet of the airflow, the outlet of the flow, walls, bottom wall, top wall, and the walls on our wedge, the base walls, and the injector of hydrogen. So we have several parts. How to do it? Let's open the parts. Right button click on parts. Create a new part. Select the first item, create part. For example, we will name it inlet at first. The name of the part. Then we should create part by selection. And for this purpose we will select some entities. Click this button, select entities. And now we should use only curves of our geometry. And we should make forbidden the selection of points. So click on the points and you see this option that is forbidden. We should make the same with planes, faces, and the bodies. The only part which is not forbidden is curves. Now let's select the part which will be called inlet. It consists of two lines, two curves. We click on them. Now it's black colored. And to confirm this operation, we should click on the middle point of the mouse. Middle means done. Click on the middle button. The color has changed and we get the inlet part in our tree. Now let's do the same with outlet. Call this part outlet. Click on this curve and middle button. Finishing this operation. Now we have the outlet part in the tree. The same for bottom part. We'll call it bottom. Select it, click middle button, and we have it. The same with top. It consists of two parts. We'll call it by one name, top. Middle button. Now all the external geometry is ready. Named parts are created. Let's go to this part. First, make it bigger by using box zoom. So the one wall will call wall 1. Wall 1. It is here. Middle button. Wall 2. Then base 1. And base 2. And this part will be called inlet H2, the inlet of hydrogen. Select it and click middle button. So very good, we have all our parts ready for other operations. Okay. Click dismiss for making parts. Close this window. Fit window. Click. Now we have the whole geometry. And we have two different parts of our flow. The main flow and inside of the flow we have the solid body. We should make these parts, separate these parts. For this purpose we make the following operation. We use the create body operation. And call one part of the flow, the name will be flow, and select it by the option centroid of 2 points. These 2 points should be located in so way that the centroid of this point will be inside of our part. So I use select location and use the following points: point 1, point 2. And confirm this operation by using middle point. And you see that the centroid of these points is located inside of our flow region. So the part is called flow and it's inside of our flow. The same we should use for solid body. I make it bigger and I will use 2 points, this point and this, but at first I should make the other name. I will call it solid, and again I will use centroid of 2 points, first point and the second, and middle button click. And you see that the solid body, the point, the centroid is located inside of our wedge, which is solid body now. So again I repeat it, we have 2 parts, plain parts, solid and flow. And we separated them. The next operation. Now we will make the so-called blocks for our geometry. We are going to build a Gexa mesh, and for this purpose we use blocking operation. So let's go to the page blocking. Select create block button and create a block around our flow body. The part is called flow. The type, of course, we will change 3D to 2D planar. Make it. And call OK. We got one block. Our flow region consists of different parts, so we should split this block to several parts. The first part, let's use the following operation: the split block button. Split block button select. The first option, split block. Then select edge on which we will split our block. Let's use this horizontal. You see that we can move it using left button. Put it near the H2 injector, the right part of the wedge. It's not very important to put it exactly on this plane, on this study of on this part of our operation. And to complete this operation, we again use the middle button of the mouse. Now it's split into two blocks. Again, let's split our block into two vertical blocks. Use this edge and click middle point, and one more edge. And now the vertical splitting near this point. Again, middle button, sorry. The configuration is so that this block should be deleted, but it should be deleted in a special way. And this block should be connected to our solid body. How to do it? At first, make it bigger. What should we do? At first, we should connect this block with body, solid body. For this purpose, we click on in our tree, right button, click on solid, and select add to part. Then we should use the blocking material. this button, and connect this solid body with block which is numbered 22. Maybe you have the other numbers, but it's located here. I choose this and again click middle button. Now you see that it has changed the color, and now it's connected with this solid body. Click dismiss. OK. And now we should delete this block. How to do it? We will go to Merge Vertices Operations, Merge Vertices. Click it. Select the third operation, which is called collapse blocks. The operation is in ICEM, it is called collapse blocks. Not delete, but collapse. So we connect this block and this, collapsing these blocks, deleting this block. Select it. At first we should select the edge which is connected with this block. It's this edge. We selected it and again use middle button. And then we should select the block which will be deleted. Click it. And again middle button. Oh, very good. We connected two blocks and deleted the middle block. Dismiss. And I think that it's high time to save our project. Now we should make the associations of our curves and edges. You see that our flow contains points and curves. The corresponding blocks consist of edges which will be associated with curves and vertices which will be associated with points of our flow region. To make this operation, we at first go to Associate button, this yellow finger button, and make the association of vertices and points, the first button. How to do it? Let's select vertex, for example on this one, click on it, you see it appeared in the vertex text box, and then we should select the point where it should be located. Click here. The same with this vertex and this point. They seem to be in the same point on our sketch, but we're not sure that it's really so. So we should make the association by not automatically, but by selecting these options. Next, this vertex, and this point. Next, this point. And now let's go to our wedge. Make it bigger. And make the associations. Vertex. Vertex. This point. The same. Oh, sorry, I forgot to make the very important thing, but let's at first do it. This point, this vertex should be here, and this vertex should be here. We must split this block into 3 vertical parts to make the part which will be associated, the part of the block which will be associated with inlet H2. So let's do it. At first, we right click on the blocking in the tree and select index control. The following thing appeared, and we can close for indexing some vertices. We'll close this one and this. How to do it? Let's increase from 0 the I dimension to 3. So some parts of our blocks now are not seen, and we will split on this. This is has been done for better splitting of our only this block. We should not split the block which is located to the left part of the wedge. Make it bigger. Again, go to the split operation, split block. Select edge. I will select this as and put it somewhere here. Okay. And one more split an operation. Put it here. And now dismiss. That's okay. So let's continue the association of this part of our geometry. We begin to associate the points. Let's continue. So let's make, oh, it's okay. Select Associate button. Vertex. And point of our injector. Now these points are associated. And the same with this vertex point. Now all blocks which are written here in blue way are associated with our geometry. Now let's associate, let's again in index control, let's again change 3 to 0. We will see all paths. Так, so let's go to associate edge to curve operation. I have some better to clear this point in order to see, not to see some lines which spoil our sketch. So we should use edge association for all our parts. It's very important. Base 1, base 2, bottom, flow, inlet, inlet H2, outlet, solid knot, top, wall 1, wall 2. We should use association for all these edges. So let's begin. The edge which is associated with inlet. It consists of two parts. We select both parts and confirm it by middle button. Now we should select the curves, the inlet curve, which are curves on the inlet part. It also consists, the inlet consists of two curves. We selected them and click middle button. Then top. The edge, we use 3 edges for this part. Select them, red color, and middle button. Then the curves 1, 2. These curves are on top part, and also confirmed by middle button. We may try to show the association by the following. Let's click on the edges by right button and select Show Association. We see arrows which show the association of edges to curves. Let's clear it. Now the outlet. The outlets consist of many parts. 1, 2, 3, 4, 5. The edge consists of 5 parts. And only one part for curve, outlet curve. Middle click. And the last part of the external geometry, the edge, which consists of 3 parts, will be associated with bottom curve. We made associations for external geometry, and now we will make the associations for the verge. Select this edge, middle button, and this curve, middle button click. The same for this edge. Then for our base regions, select middle button, curve, base 1, middle button click. The same for base 2. And for inlet of hydrogen, select edge and select curve. I hope that association has been done. Now choose this button, which is called Snap Project Vertices, and click OK. We see that association has been done. It's okay. Now let's try to build our mesh for these blocks. For this purpose, we must go to the mesh page here. I repeat, mesh, select, and select the option Curve Mesh Setup. Curve Mesh Setup. Click here. We will select all our curves. How to do it? Click on this button, select curves, and select all visible curves by using this button, which is called Select an Appropriate Visible Object, to show all the visible objects. Click here, and you see that all our curves are selected. The maximum size of our mesh. We remember that this is about 50 millimeters. I think that 5 millimeters will be okay. So maybe no, I think 2 millimeters will be okay, or even something like this, 1.5 millimeters. In ICEM CFD, meters are used as units, so we remember that we should use meters here and not millimeters. Click OK, and return to the blocking page. Return to the blocking page. Select the button which is called Premesh Params. Premesh Params. Be sure that we have selected the first Update Sizes button. By this operation we connect the mesh dimensions with our blocking dimension sizes. And click OK. Now let's check the Premesh option in our tree. I repeat the Premesh option in blocking in our tree, and click Yes for the question to recompute or not. Sure that it should be yes. And we build the mesh for both parts for flow by this operation. It's not bad mesh, but we will improve it. And the mesh is built for our solid body, which is not good for our solution, is not useful, will be not used. And to tell the truth, that the mesh in the solid body is very bad, because some of the parts are not very good. So let's delete the solid from our parts. By this operation we delete also the mesh which is built for this part. Right click on the solid and use delete operation. I repeat, solid which should be deleted. Answer on this question: delete, and we will recompute our mesh. Yes. And now you see that mesh is built only for flow region. Is it good or not? I think that we should improve it. At first, we will make more nodes in the inlet of H2, and near the base region we will make the mesh finer. So let's begin. Make this part bigger. Let's change the number of nodes which are placed on the input of H2 inlet. For this purpose, let's go again to Premesh Params. And now use not update size, but the third option, edge params. The edge params option. Select this edge, not path, not curve, but the edge, because we are building our mesh on our blocks, not on the geometry. Click here. We see that we have only 5 nodes. It's not enough for our operation, of course. Let's make it about, I think 20 will be enough. 20 nodes. And click Apply. Please remember this number. It's the size of our mesh in vertical direction. Let's build our mesh again. Clear the Premesh Params checkbox. And again, check it. Oh, you see that now we have very fine in vertical direction mesh, but it's not very good that the size of the mesh here is very different, much different from this dimension. So let's improve this part and this. At first, base 2. Select this edge. We have only 4 nodes. I think we will change it to 10 nodes. And we must change the spacing of this, the location of these nodes. For this purpose, we must use the spacing 1. Change it to 9e minus 5. You remember the size of the inlet H2 mesh vertical size. It was something like 8E minus 5. We should use here the very close value, a little bit bigger. And the ratio of the sizes we must change to 1.2. It's good ratio 1. And click apply. The real sizes and ratio are shown on the right part. And then again change the premesh. Clear and check. Yes. You see that the sizes are changing and the first mesh is very close to the inlet size. Let's make the same with the base 1 region. Select this edge. The number of nodes is 10. And now the size 2 is located here, because arrow, it's not a very small arrow, but it goes from this point. So the first spacing is near this point, and the second spacing is near this point. So let's change the spacing to the same number, 9E minus 5, the ratio to 1.2, and click apply. And build premesh again. Not so bad. We are interested in the near wall flow. So the size of this mesh should be smaller in the vertical direction. Let's select the edge, this edge. The number of nodes we will not change, but the spacing will be, now it's 1E minus 3, 1 millimeter, about 1 millimeter. Let's change it to something like this. And now it's better to use this spacing on all parallel edges. So let's check this option, copy parameters. Please check it. Let's try. Apply. No, I think it's not enough. I will change it to 2 0 3 0 2. Oh, ratio. I forgot the ratio, of course. 1.2, also spacing 1. Apply and try to build Premesh mesh. Oh, now it's not bad. But this size is very much differs from the point. Let's change again the base to edge. How to do it? I select edge. Maybe 15 nodes will be better. And 1 E minus 4 will be used here. The ratio the same. Apply and rebuild mesh. Yes. Oh, now it's okay. Very good sizes. They are very much alike. And let's make in the lower part. Select edge, which is associated with base 1, nodes 15, spacing 2, 1 E minus 4, the ratio the same, apply and rebuild mesh. Recompute. And the same with the edge which is located here. We will not change the number of nodes, but you see the arrow is located from this point to upper direction. This is why we should change the spacing to. I remember that it's about 2. The ratio 1.2. Apply and recompute our mesh. Oh, that's all right. The next operation, the size of this mesh, these cells of the mesh, should be reduced in the horizontal direction. How to do it? We shall choose this edge, the direction of arrow from left to the right. So we should work with spacing 1. Now it's about 1.5 millimeter. Let's do it something like 2.0302 of the millimeter, and the ratio also 1.2. Apply and recompute our mesh. Oh, that's all right. I think it's very good mesh for our operation. But I don't like the mesh on the right part. Let's go here. And I think that we must move or maybe not. Maybe it's okay. Oh no, I will move some vertices. Let's go to blocking operation. Here we have move vertex. I fix X and that direction, so I can move vertex only in vertical direction of Y. Choose this vertex and move it a little bit higher. Middle button. Recompute the mesh. And the same I will do with lower vertex. We move it a little bit lower. Middle button. Yes. Not symmetrical, but makes no difference. And I think it will be better to make the change the sizes here. So again, go to Premesh Params, edge. I choose this, select this part. Very important, I should not spoil the previous part or words, so I should use these sizes only for this edge. So let's clear the copy parameters. It's very important. Please remember. Otherwise, we will have problems in the left part of our sketch geometry. I shall make the spacing the same. For this purpose, I everywhere put 0 and apply. Recompute. Yes. Now it's equally spaced. and the dimension, the size is 4/10 of millimeter, about 4/10. Remember this. That's the same make with this edge. Everywhere 0. Make sure that the copy parameters is cleared. Apply and recompute. Okay, but I have not very good here on this edge. Change here. We have there 4/10 of millimeter, and here about 2/10. Let's change it to 5/10, half of the millimeter. Apply, recompute, and the same here. Edge. Only 1/10 of millimeter. Let's change it to 5/10. Apply and recompute. Oh, I think now it's not bad. Mesh. Let's save our project. And now we build it structured, regular mesh. Let's change it to unstructured mesh, because the Fluent, which we will use, works with only unstructured mesh. So right click on Premesh Params, and select Convert to Unstruct Mesh. I repeat, right click on Premesh in the tree and select Convert to Unstruct Mesh. Very important. Always use for this operation not merge but replace. So click on Replace. Otherwise you will have very bad complicated mesh, which will not work for sure. Replace. The premesh is cleared, but now we have mesh. Let's check shells. We see the same mesh, but now it's unstructured mesh. We converted the blocking mesh, which was regular, to unstructured mesh. Let's make the output file, which will be used in the next operations. Choose the page output mesh, the last page, output mesh. The first, select solver. We will use solver of Fluent, ANSYS Fluent. So apply. Then make sure that we associated all our paths with edges. Open this page and open the edges in the tree. base 1, base 2, bottom, inlet, inlet 2, outlet, top. I think it's okay. Let's compare with the paths. Here we have edges associated with paths. All edges will should they have the same names. Base, base 1, bottom, inlet, inlet 2, H2, outlet, top, and 2 walls. Okay. And the last operation is write input. Save current project, yes. Okay. Open. And you should make the following operation for sure. Change the grid dimension from 3D to 2D. Do it for sure. And it's better to write not binary file, which is hard to read, to ASCII file. So you select no for writing binary file. I repeat, 2 dimensions, 2D, and no in writing binary file. Done. So I think it's builded and it's ready for next calculation. Let's save our project and close ICEM window. On the next lesson we will try to use this mesh for calculation of our flow. So thank you. This lesson is finished.